So the first thing I want you to do is go through and factor these two different problems as completely as you can, and then unpause the video when you're ready to go through the correct answers. Okay, so on this top one, since there are 4 terms, you can factor this by grouping just right off the bat. There is a GCF though, so I'm going to take that out first. So I'm going to pull out an x, and then it's 4x cubed minus 4x squared minus x plus 1. And then since it's 4 terms, we can factor by grouping. So I can pull out a 4x squared, and this will be x minus 1. On the back, I can pull out a negative 1, and it will be x minus 1 as well. So when I first factor this, I have an x from my GCF, I have 4x squared minus 1, and I have an x minus 1. But again, like we did before, if you have a squared term on your x, you want to keep going to really factor it completely. So I'm going to factor this one. That is a difference of squares pattern. And so if I square root 4x squared, I get 2x. I square root 1, and I get 1. So I need a 2x minus 1 and a 2x plus 1. And then this x minus 1. So the fully factored version is going to be that. On this second one, you are going to use your x method to factor it. It does not have a GCF, so we're just doing 5 times 24 is 120, and then adding to 23. The numbers that will do that are 8 and 15. When you go through this, 5x to the 4th plus 8x squared plus 15x squared plus 24. You can pull out an x squared. You're left with 5x squared plus 8. And then out of the back, we can pull out a 3, and we're left with 5x squared plus 8, which gives us this. Okay, again, when we're factoring, I want you to look and see if things are prime that you still could force to be a pattern, like we have done in our on day 2 of the notes. So while x squared plus 3 is technically prime because it's addition, we can force it to be our sum of squares pattern. And so we're going to do x squared is x, and then it's plus I root 3, and x minus I root 3. For the second one, again, it is technically prime, but we are going to keep factoring it by our sum of squares patterns. So this will be x times the square root of 5 when you square root 5x squared, plus square rooting 8. You can simplify that radical. So the square root of 8 is really 2 root 2. Because this is sum of squares, it needs to be 2i root 2. And then x root 5 minus 2i root 2. Okay, again, with honors, we're practicing factoring as far as we can and forcing things that are prime to factor also to just get used to those patterns. Today we're going to talk about how you apply this. And the nice thing with today, you can use really any level of this. So you could stop here and get an answer, or you can keep going. So for some people, you're going to prefer to keep going to the fully factored form, and other people will prefer to use it from here, and I'm going to show you how to do that no matter what. If you have any homework questions, feel free to pause the video and take time to talk about those if you need to. Anything else that you need me to talk about with, we can go ahead and talk about when I get back next class. What we're doing today is we're talking about how to solve quadratic and higher degree equations. So in regular algebra 2, they'll only talk about quadratics, but here we're going to push it a little further and talk about really just all polynomials and how you can solve them. Next chapter, we talk more about solving polynomial equations because I'm only going to teach you how to solve a certain subset of polynomial equations today. But it will make everything we do later on a little bit easier because you'll have already seen much of it. Again, as we go through this video, feel free to pause it as you need to make sure that you have time to write things down, but I am just going to keep talking through it, but feel free to pause it. Okay, when we're solving our equations, we are going to be doing what we've really done before in every other chapter. When you're solving equations, the main goal is that it's going to find you all of your zeros or your x-intercepts. Okay, well, now we start using different words for these, and it will all help a little bit later. But x-intercepts we sometimes call zeros, because really your y just equals 0, and you set it equal to 0. We also call them roots. Okay, so any of those words are interchangeable. When you're solving these, you're going to have multiple correct answers because a lot of these graphs have multiple x-intercepts depending on what it looks like. So when you're deciding how many answers you should have, it will change on every single problem, but it could be up to the number of your highest exponent or of the degree of your polynomial. So if you have an x cubed as the biggest exponent in your problem, you should expect 3 answers, or up to. It will not always be perfect. What I'm going to talk about first is 3 different key methods that you will use. These are going to focus on when you have a quadratic, so an x squared, but then we will go through examples where we apply this to our higher order roots when you have a larger degree. Or not higher order roots, higher order polynomials, I apologize. Your first method is solve by factoring. And the first thing you're going to do in this method is you need to set your equation equal to 0. So EQN means equation, because the only way we can actually solve this is if it's equal to 0, which will be your first step when you're finding your zeros or your x-intercepts later. And so with this one, we're going to minus this 3 over, and you will have n squared plus 7n plus 10 equals 0. Once you have done that, then you can go ahead and factor however that may mean, whether that's a special pattern that we've learned, whether that's with your x method, whatever it is, you're going to go ahead and factor. This one, because it's a trinomial, we're multiplying to 10 and adding to 7, which is 5 and 2. You'll go ahead and factor that by grouping, and what you should get is this, n plus 2 times n plus 5. It's still equal to 0 because it's an equation. Once you have factored, you are going to apply what we call the zero product property. What the zero product property says, if you have two numbers multiplied together, so say a times b, or they could be quantities like we have here, our whole parentheses is our a and our b, and they equal 0, then either a has to equal 0 or b has to equal 0, because otherwise you can't, the only way you can multiply to 0 is if one or both of your numbers is 0. So how we can apply that, we're going to do n plus 2 equals 0, and we're going to do n plus 5 equals 0, and we're going to be able to solve this. So your final answer for these equations when I ask you to solve will be the number. So here when I solve the first one, I get negative 2. When I solve the second one, I get negative 5. Done. So that is your first method you're going to learn. The second tool you can use is what's called solve by square rooting. And this comes in especially handy when you have a difference of squares pattern. It makes those rather easy to solve. But your solve by square rooting method, what's important is that you have an ax squared term and a c term, but nothing else. You do not have a bx term, which is why it's helpful with your difference or sum of squares patterns, because that's all you have in those patterns. With these, the first thing that you do is to isolate your x squared term, your quadratic. So here I would divide by negative 8, divide by negative 8, and you get v squared equals 16. Then, anytime you have a squared something equals a number, what you can do is square root both sides, because your square roots and your squareds undo each other. Oopsies, sorry, direct what I was saying. And you would get v equals 4. There's an especially important part here because this is not my final answer. When you have this, remember you should have the same number of answers as your highest exponent, which means I should have 2, and 4 only gives me 1 answer. When you are solving an equation, anytime you square root both sides, you have to remember to do a plus or minus in front of your answer. So this answer isn't 4, but it's plus or minus 4. The reason for that, if I plug in positive 4 into my v squared, I would do positive 4 squared is 16, and so that checks out. But if I plug in a negative 4 squared is also positive 16. So both versions, the positive and the negative, work out. So you have to always fill in that plus or minus, but this one is done. The last method that I'm going to put in your toolbox for these is the quadratic formula. Your quadratic formula is actually the only of the methods that always works so long as you have a quadratic equation. This does not work if your equation is raised to the 4th power or the 5th power or the 3rd power. Your degree has to be a 2 in order to use the quadratic equation. So that is extremely, extremely important. If you're going to use the quadratic formula, you do have to set your equation equal to 0 first, just like when you're factoring. So here I'll move that 10n over. So it's 12n squared minus 10n minus 15 equals 0. And then you're going to plug everything into your quadratic equation. You will have to have this memorized. You should have seen it before in Algebra 1. I will give you slightly more complicated ones than you saw back in Algebra 1, but this formula right here has to be memorized. When I plug into it, my b is negative 10, so when I plug into negative b, negative 10 is positive 10, plus or minus the square root of negative 10 squared minus 4 times 12 times negative 15, all over 2 times 12. When you're simplifying this, I would specifically first simplify your radicand, and then when that is done, simplify your fraction. Okay, so I will start inside the radical with that number under there. When I do, negative 10 squared, it's 100, and you're going to multiply everything at the back, and you should get 10 plus or minus the square root of 820 all over 24. And then you do need to go ahead and simplify that radical. Okay, so you need to find me the largest perfect square that goes into 820 that you can pull out. So take a second and do that. The largest one that does go in is 205, or sorry, it's 4 times 205. So when I simplify that, I'm going to have 10 plus or minus 2 root 205 all over 24. Okay, then we need to simplify the fraction. What helps some people is to split it apart. I'm going to write small because I'm going to run out of space. But this 24 really applies to each piece up here. So I'm going to separate it so that it's easier to see. So this is 10 over 24 plus or minus 2 root 205 over 24. When I simplify this first one then, 10 over 24, you can divide it 2 and 2, so it's 5 over 12 plus or minus root 205 over 12 also, because this 2 and 24 can simplify. Some people like to leave it together in one big fraction and just simplify it, and some people prefer to split it apart. I'm not going to be picky so long as you realize that these would be the same answer. So you could write it as 5 over 12 plus root 205 over 12, or you could write it as 5 plus or minus root 205 all over 112. What's important is that you recognize that those are the exact same thing. Okay, so these are your 3 different methods that you're allowed to use as we go into solving all of our equations. So now they're going to look a little bit bigger, but you're really just using the methods we've just talked about. You can factor, you can solve by square rooting, and you can quadratic formula once you have a quadratic. So when we look at this problem, we need to think about what method would work. With this, I have 4 terms, which looks a lot like my warm-up, where we can actually factor it. So the first thing I'm going to do is factor this by grouping. And your answer for the first step of factoring, oopsies, this should be a 1, is this. And this is where you really have multiple options, and this is why we've talked about factoring as much as we have, is because you can do a couple different things. First off, you could apply your sum of squares pattern to this one and keep factoring it. Or you could, if you didn't want to keep factoring, you could instead solve this by square rooting like we just talked about a minute ago. So I'm going to keep factoring it just to show you how that would work, but you could also do it the other way. If I keep factoring this is a sum of squares, so it would be x plus I root 3 times x minus I root 3 times the x minus 1. Our zero product property then tells us that if all three of these numbers multiplied together equals 0, then at least one of them has to be. So I'm going to go ahead and set each of these equal to 0. And when I solve it, this first one I would subtract the I root 3 over, so I'll get negative I root 3. Second one I would add it over, so I'll get I root 3. And the third one I will get 1. What's very important that you see is that this is not the only option. With this problem, you could also have immediately set each of them equal to 0 without factoring further and solve by square rooting. So I'm going to show you how I would have done that. So if I wanted to square root this, I would isolate my x squared, and then you would square root both sides. You'd have your plus or minus, and it's negative root 3, which would give you plus or minus I root 3, which is exactly what I got right there. You could have also quadratic formulaed that equation if you wanted to. Okay, there's multiple ways to get to the same answer. With this, it is important that you notice that you should have had 3 answers because it was an x cubed. I do have 3 answers, and so that is good. That means I probably am on the right track. When we get to later in the chapter, what you're going to find out is this is our x-intercept, just like we talked about at the beginning. So I would have an x-intercept at 1, and these are imaginary, so they're not actually going to cross my x-axis. So the next chapter, we will use how that looks even more. Go ahead and give this one a try and see what you can figure out. Again, there's multiple ways to do it, but give it a try and then play this video to figure out the rest of it. Okay, when I go to factor this, there's a trinomial, so I'm going to actually try to use my factor diamond. Multiplying to 9 and adding to negative 10 is negative 9 and negative 1, and then you're going to factor it all the way through. What you should get after you factor by grouping is that. Again, make sure you show all of your work there. Now I really have 2 options, just like I did on the last one. I can either set each factor equal to 0 and I can solve by square rooting, or I can realize that this is a special factor pattern and that these are both difference of squares, which is what I'm going to do. So x squared minus 9 gives me x minus 3 and x plus 3. X squared minus 1 gives me x minus 1 and x plus 1. And then I can set all 4 factors equal to 0 and solve from there. It's actually good that I have 4 factors because my biggest exponent was a 4. When I do this, from setting x plus 3 equal to 0, I'm going to get x equals 3. Or sorry, x minus 3 gives me x equals 3. When I set x plus 3 equal to 0, I'm going to get negative 3. When I set x minus 1 equal to 0, I get 1. And when I set x plus 1 equal to 0, I get negative 1. So these would be my 4 x-intercepts of this function if I went to graph it. If you need to go back and listen to this one again or ask questions together, that is totally fine. What I want you to think about first is what special pattern this one is. This one, while it may not look exactly like it, is actually a sum or difference of cubes. So the first thing I'm going to do is split this up with our sum or difference of cubes pattern. If you need to look up what that looks like, then I would do that now before continuing on. Okay, my sum or difference, or sorry, this is a sum or difference of squares problem. It will be a cubes in a second. I apologize, I overstepped there. This is a sum or difference of squares first. And what's important, if you have one that could be either, because I could view this as a cubes or a squared, always do your difference of squares first. So when I do this as difference of squares first, I will split it up as x cubed minus 1, x cubed plus 1. So always, again, I apologize that I misspoke. You want to do your difference of squares first before difference of cubes, if you could do either. Because now it's going to give me difference of cubes that I could split apart. So this difference of cubes will be x minus 1 times x squared plus x plus 1. This difference of cubes will be x plus 1 times x squared minus x plus 1. Okay, and then we can keep going from there. This one gets a little complicated. First off, you do have two answers you know right off the bat. So right now I know x equals 1 from this first one and x equals negative 1, but I still have more answers embedded in those quadratics. The problem comes in that if you try to factor them, it's going to be impossible. So we will have to quadratic formula both of these, and the reason for that, again, if you try to multiply to 1 and add to 1, nothing will work. And the same thing happens if on the second one you try to multiply to 1 and add to a negative 1. Also, remember when we talked about your cubes on the first day, your sum and difference of cubes, we said that they will never be factorable. What that means for you here is you are going to have to quadratic formula these. So I'm going to give you a minute to try that. And really pause the video and then play it when you're ready to hear the explanation. So when I quadratic formula this part, it's going to be x equals negative 1 plus or minus the square root of 1 minus 4 times 1 times 1 all over 2 times 1. When you do that, 1 minus 4 gives me negative 3, so it's really I root 3 over 2. Okay, and that can't break down anymore, I can't simplify it. That does give me two answers because of that plus or minus. And so that's another 2. Then I'm going to do the same thing for this part. And really all that changes is that negative 1, the 1 in the first problem is now a negative. So our problems are going to be very, very similar. Do be careful here. Negative 1 squared is still positive 1, so it's still a 1 minus 4, which is a negative 3, or an I root 3 over 2. Again, you can't simplify it anymore, so this is done. These are my 6 answers to this equation. Go ahead and try this one for some extra practice. When we do this one, you're multiplying to negative 24 and adding to 5. The numbers for that are going to be 8 and negative 3. So go ahead and make sure you factor that all the way down. Okay, and it would look like this after your factor by grouping. This one you can keep factoring and force those to be your difference of squares or sum of squares patterns. Since last time I did that, and this time instead I'll show you how I would do it if I were solving by square rooting, but please remember that you can do these either way. You will get the same answer so long as you do it correctly. If I'm going to solve by square rooting, I'm going to set both factors equal to 0 and isolate my x squared. So this is x squared equals negative 8, or x squared equals 3. Square root them. This needs to be plus or minus. When I simplify square root of 8, that's 4 times 2, so it's 2I root 2. And when I solve the second one, I just get plus or minus square root of 3. Again, if you force these to be your sum or difference of squares pattern, it will also get you the same answer. You can do it either way, whatever you prefer. The last thing we're going to talk about is how you would solve radical equations that are going to involve you having a higher degree polynomial. Last chapter we skipped ones that would involve this because you didn't have this skill yet, but this chapter we're going to be able to do that. So if you think back to last chapter, first thing you had to do was isolate your radical, which this is already isolated, and then we're going to raise both sides to our inverse power. So here we're going to cube both sides. On the left it just cancels. On the right, make sure you cube both things. So this will be 8x cubed. When you're setting this equal to 0 so that you can try to factor, I would make sure that you keep your highest exponent positive. So I'm going to move everything to be with this 8x cubed to make my life a little bit easier. And then I'm going to factor out an x because this all has a GCF. And then you want to try to figure out if you can factor this equation or if you are going to be required to quadratic formula it. Just to show you, you can, even if you can factor problems, you can always quadratic formula. Some people do prefer the quadratic formula, but if you're ever not sure, that will work. This one you cannot factor, so we are going to quadratic formula it. So I'm going to plug this in as my A, my B, and my C. Okay, and when we do that radical, 1 squared is 1, minus 4 times 8 times 7 gives me negative 223. So I'm going to pull out that I right away. All over 16. I believe 223 is prime, so this we can't keep going. So these are two of my answers. Your third answer, because I should expect 3, will come from this GCF of x that we pulled out. So you would technically set that x equal to 0, and that it's already solved, so I have my 3 answers. One thing I want you to remember is when we solved our radical equations, we had to plug everything back in to verify that it worked or not. One thing we talked about then was technically with odd roots, you do not have to check it. So since the index here was odd, we don't have to plug everything back in, but I'm going to show you how we would do that on the next problem. For example, this one. So on this one, first thing we're going to do is isolate our radical. So I'm going to move that m to the other side. So this is 7m minus 54 equals m minus 6. Then we're going to square both sides to undo this radical. But on the right-hand side, what's super important is that you FOIL that binomial out. You cannot just distribute the squared. Since it's a binomial, you have to do it all the way out. And so you should get m squared minus 12m plus 36. And then we need to set it equal to 0 so that we can factor. Again, I try to get everything to be with my m squared so that that stays positive. So I'm going to move the 7m and the 54 to the other side. Okay, feel free to pause so that you can try to factor this and finish solving real quick, but then I'll keep going. That should be your numbers that you're using, and when you finish factoring, this is what you should have. Setting your factors equal to 0 and solving, you should get that m is 10 and that m is 9. Remember though that you are not done just because of that. Since you squared both sides, there's a chance that our answers don't work, so we need to make sure before we finish. When you're plugging them back into check, you can either check in your original or you can check in the problem before you squared it. So if I, for example, check here, you're making sure that the square root of whatever 77 times 10 minus 54 is equal to whatever 10 minus 6 is, and that 7 times 9 minus 54, when you square root that, it's equal to 9 minus 6. Okay, on this first one, you do get the square root of 16, which is equal to 4, so that checks. And on the second one, you do get the square root of 9, which equals 3, and so that works. Both of these answers do work. with these equations. Sometimes one will work, sometimes both will work, sometimes neither will work. There's no real way to know until you work it out. This last one is going to be the most challenging one. On a problem like this, you have two radicals as well as something happening outside of your radical, so specifically that one. So we are actually going to clear our radicals kind of slowly, really one at a time. What I'm looking at right now is that this radical is isolated, and so I'm going to square both sides to get that radical on the right-hand side to go away. So while that's all nice and pretty, I have to FOIL this. Since it's squared, I'm going to write it out twice, and I'm going to FOIL this binomial. And this gets a little hairy, so stay with me. Feel free to rewind and watch this part a couple times if you need to. When we do this, the first thing you're going to do is the root 1 minus 4x times root 1 minus 4x, which is really just square root of 1 minus 4x squared. So those radicals just cancel and you have 1 minus 4x. When you do the square root of 1 minus 4x times negative 1, you get negative 1 root 1 minus 4x. Then you do this negative 1 times the negative 1 minus 4x. And then lastly, you do negative 1 times negative 1 is positive 1. I'm going to make this look a little nicer in here. What should happen after this step is some of your radicals cancel, but not all of them. However, you should be able to simplify it down a little bit. These, while ugly, are technically like terms. So I really have negative 2, if I do negative 1 minus 1, square root of 1 minus 4x. Combining the rest of my like terms, I have a 1 and a 1, so this is plus 2, and then minus 4x equals 4 minus 2x. We now basically have to start all over and isolate this radical so that I can try to make that go away. When we do that, I'm going to subtract 2, so I get 2, and I add the 4x, so plus 2x is equal to negative 2 square root of 1 minus 4x, and then divide that negative 2 over, and you get negative 1 minus x. So again, I first subtracted the 2 to the 4 and got 2, added 4x to negative 2x and got 2x, and then divided by negative 2 on everything. Now this looks like a problem you could have done before. So we're going to square it and square it. I get 1 minus 4x. When you square this binomial, be careful with all those negatives. You should get 1 plus 2x plus x squared. Again, I'm going to set it all equal to 0. I want everything to go to my x squared term. These 1's actually cancel, and I have x squared plus 6x. Remember to be careful when you get to this part, because sometimes we try to make factoring harder than it is. This you can just GCF. And then your answers are 0 and negative 6. Again, you are not done until you have checked it in the beginning of your problem, or before you squared it, which for us really is the first thing we did. When I plug in 0, it'll look like this. 1 minus 4 times 0 is square root of 1, so this is really 1 minus 1, equals 4 minus 2 times 0 is really just 4, so 2. These do not equal 1 minus 1 is 0, so 0 is not an answer, so we'll cross it out. Negative 6 might still work, but 0 we're getting rid of. Okay, when I do this one, 1 minus 4 times negative 6, this is really positive 24 plus 1, so this is square root of 25, or 5 minus 1. And I need to know if that equals negative 2 times negative 6 is really plus 12. 4 plus 12 is square root of 16, which is 4. And those do check out. So my only answer here is negative 6. I'll write it nice and big over here. 0 is not an answer, but negative 6 is.